All right, you have to tell me if you can hear me. Um, I had to do the live stream at home, so I had to set up some things, and then I had some internet problems, and it was bad. So I'm doing a volume check. Just letting you know if you can hear me. It looks like you can, but I'm not really sure. So if you can hear me, let me know. And then okay, good. Thank you, because I don't have my earphones here that I usually use. I have them at school. And since I have to leave school, I have to make sure that you can hear me. Okay, yes, Helena, let's do this. So I'm just trying to figure out how to use I'm using my cell phone as a webcam because I don't actually own a web camera. So it's going to be a little different. Iris, you can't hear anything. So try turning up your volume. Your computer might be on mute. I'm not speaking very loud, so that could be it. Um, yes, Ava, I see your name. It says Miss Bass. Do you have a question? Yes, I saw that. Iris can't hear me. So I'm going to see if her turning up her volume works because I have I have bars. Okay, so you can't hear me and you've turned it up all the way, huh? Did you try? Let's see. I have turned up my microphone all the way. Are your speakers on? I only laugh because I do that all the time. So let me know. No, your speakers aren't on? Because I don't want to start. Oh yeah. If it's on silent mode, then you're not going to hear me. So I can't hear videos when my ringer's off either because it's silent mode. So I'm just gonna wait and see if she turns on her ringer, if that helps. Because Khadija had a really good. Oh no, you can't see or hear me. If you're on the blog, then you'll only be able to watch. Um, if you're on the chat, try refreshing your screen. So on the address bar, there's a little arrow if you're on a Mac, or beside the address bar, there's a little arrow if you're on a Windows computer. Try refreshing it because I did come in a little late. So you might have to refresh your screen, or you might have to close your window and go back into YouTube. I only do streams. I try to do them for about 15 minutes. I just want to make sure you have if you have any questions, I can answer them. Go through a couple questions. I like to show you a little bit of what's going to be on the quiz so that you can prepare. But that's it. You can't see Miss Bass. You can see a piece of paper and now my hand in a few seconds because I have a lag here. I'll give you my thumbs up. Yay. If, oh, good. What was the problem? You have to tell everybody because they're going to wonder. Okay, so um, I have some of the sheets that I left on the blog if you wanted to do some preparation. Just to remember that these are all um, theoretical probability, and you have to know the difference between theoretical and experimental probability. That's going to be really important for your test. Okay, so because it's just me tonight, Miss Beck's not here. I'm going to not be able to watch the chat as closely, but I'll look back once in a few minutes because I'm going to do the math first, and then I'll answer your questions, and then I'm going to do more math, and then I'll answer your questions. Um, because usually Miss Becca's here to help me, and she gives me a signal if there's a question, and I'm kind of by myself right now. So it's a little bit harder to do. Okay, so I'm going to start with, I know I get this done quickly. I want to get this done by 5:30 because I started late. My fault because I had everything ready and then my internet went down. Anyways, who cares? Um, so right now we're going to look at, this is a spinor probability question, and there's a spinor. So what I would do is I would collect all of my information first about the spinor. So when we're doing a probability ratio, there's two numbers we need to know. We need to know the possible outcomes, which is the number of pieces that we're looking at, and then there's also any sort of variables, okay? So I have a spinor here. First thing I'm going to do is going to count the wedges. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. So there's 7 wedges, which means my outcomes are 7 because there's 7 in the hole. Okay. Any events are going to be on the right hand side, but all the outcomes, because there are 7 wedges, my second number is going to be 7. Okay. So whatever probability is, we're going to have a ratio, and it's going to end in 7. So if we look at number 1, it already asks you how many pieces are in the spinor because that's an important step. So we already did that. Yay for us. Okay? Even if it doesn't ask you that, it's probably good to have that information somewhere because that's going to be the second number of your ratio. So let's look at question number 2. If you spun the spinor one time, what is the probability that you would land on a gray piece? So it just says a gray piece. So the thing about probability is it's a lot of reading, and you have to make sure that you pay attention to the details. So remember when we did UPS? That was a way of trying to get you to look at the details. So if we look at this spinor here, we can see that there's 2 light gray and 1 dark gray, but they're all still gray. So if I count those pieces, 1, 2, 3, there's 3 gray pieces. Now I remember because there's 7 wedges that the second number of my ratio is going to be 7. So I'm going to say there's 3 gray pieces. I'm going to do my ratio symbol and 7. Or you can write this, remember when we did ratios, you could write it as a fraction, or you can write it as a, how else do we, 3 to 7, okay? So just like when we talked about ratios, there's 3 ways you can write your probability, okay? What you're not going to do is you're not going to give me what is the probability you land on grade, please. You're not going to say not likely, okay? Because now in grade 6 we're looking at numerical probability, okay? So we're not just looking at using words. Now we're going to use numbers in place of those words. So 3 to 7 is like saying pretty likely or somewhat likely, but now we have the proof of the numbers with it. So if you spun the spinor one time, what is the probability you would land on a black piece? So this dark gray one, I think, counts as black. There's only one of those. Okay? And I just looked over at the screen. Yes, Margot, it's black. For me, it's dark gray. So if we were going to count it as black, then we could change this to what? We could change it to 2, right? Because I'm marking your test, if I said, hey, did you think this was gray? And you said yes, I would still mark it right. Okay? All right, look at this. If you spun the spinner one time, what is the probability you land on a black or dark gray piece? And there's only one dark gray piece. So the ratio is going to be, remember our second number of the ratio is always 7. We count the number of pieces, and that's going to be 1 to 7. Okay? Or not likely. But numerically, 1 to 7. Okay? So, if you spun the spinner one time, okay, so one time is the theoretical probability. When it gives you, Andy spun the spinner 9 times, that's experimental. So you have to look at the wording of the question as well. Okay, so now I'm going to let you answer this. If you spun the spinner one time, so we're doing a theoretical probability, what is the probability it would land on a white piece? Okay, remember that the second half of your ratio is going to be 7. So what's the probability of landing on a white piece? The theoretical probability. I'm going to wait for your answers. And ding ding, Khadija wins. Khadija wins the internet today. Our probability is 4 to 7. The rest of you are right, but Khadija was first. Because my outcomes are going to be 7 because there's 7 pieces. But my events, okay, which is the landing on a white piece, is 1, 2, 3, 4. So my probability of landing on a white piece is 4 to 7. These are the best odds here. Last question. If you spin the spinner once, so we're looking at theoretical probability, what is the probability of landing on either a white piece or a black piece? This is a 2-step problem because now we have to add the white and the black. It's not very difficult, so I'm going to put my second half of the ratio so I don't forget that, because that one's always the same because I'm dealing with a spinner. Then I'm going to count the white and black or dark gray piece. So 1, 2, 3, 4, 5, and then we're not counting these two. So my event, which is landing on either white or black, would be 1, 2, 3, 4, 5 to 7 pieces on the spinner. Oh, Marco, you got it first. Okay, so you're second place on the internet. So yay, Khadija and Marco. All right, so you guys win section 1. Okay, so on your test, you're going to deal with spinners and dice, maybe some numbers like you did in your games today, okay? So let's look. The reason why this sheet is first is because if you only do one sheet for preparation tonight, I think you should do the first sheet that there is, the basic probability sheet, because it gives you a chance to look at 3 different types of probability scenarios, okay? But they all have the same sort of rules, okay? So let's look at the dice. Let's collect our outcome, okay? So what's the outcome? What is going to be the second part of our ratio if the questions are centered around dice, okay? The outcome, so the second number, okay? If you want to use a real dice on the test because it's on there, sure, you can grab one and you can look at it and count it. It's always good to know. It's always good to know how many sides are on a die, just so that you have it. So a die is a cube, and we know that a cube is 6 sides. So my second half of my ratio is going to be 6, okay? And then that means any of the events are going to be the first number in my ratio for theoretical probability, okay? If we were doing experiential probability, it might look different. Okay, so number 6, if you were to roll the die one time, what is the probability it will land on a 3? And Marco is just committed to trying to win the review because he already put the answer. But this is where we would count the numbers of sides that have 3 dots on it, right? And so usually the dice would have 6 sides, and they would all have numbers 1, 2, 3, 4, 5, and 6. So 1, 2, 3, 4, 5, and 6. Okay, so there's only one side that has a number 3 on it. So probability of rolling a 3 is 1 to 6. Those are not great odds. So if you were to roll the die one time, so theoretical probability again, what is the probability it will not land on a 2? So the probability of it landing on a 2 is the same as it landing on a 3. There's only one side of the dice that has 2 dots, so it's 1 to 6. Now, if we wanted to flip that, what would be the opposite then? If it's 1 to 6 that you would land on a 2, it would be however many sides are left without that 2. That would be your probability of not landing on a 2. 5 to 6, because I count 1, 2, 3, 4, 5, 5, and then my outcomes are 6. 5 to 6. All right, better odds of not landing on a single number. Number 8, if you were to roll the dice one time, what is the probability of it landing on an even number? So we remember that even numbers are 2, 4, and 6 on a die. There's way more, but we're only talking about what's on a single die. Okay? So we have how many even numbers? 1, 2, 3. So if there's 3, these are the events. The event is the first number. Plus, we know for sure that there's 6 outcomes because there's 6 sides on the die. So our probability is 3 to 6. Now, you will get marks for 3 to 6, but you can simplify that. So if you remember back to our lessons on lowest common multiples, our number sense talks, these are both even numbers. So we know automatically I can divide them by 2. But I happen to know that 3 is a multiple of 6. So 6, I can divide 6 by 3 quite easily. So if I divide both by 3, remember this is a fraction is just a sign for fancy division. 3 divided by 3 is 1. 6 divided by 3 is 2. And now I have my equivalent ratio, which is the lowest form for our probability. Okay, when you're trying to give people probability, especially theoretically, you want it to be the lowest possible. Okay, because that gives people a better sense. If I said you had 1 out of 2 chances of, I don't know, being kissed by a shark versus you had 12 out of 24. So, I mean, it's just a little easier to understand if we simplify it. Okay. I don't know why I said kissed by a shark. You guys get mad at me if I talk about baby heads. So I'm trying something new. All right. Here's the last section that I want to do, and then I want to move on to looking at the quiz. Okay. So this doesn't involve dice or a spinner. Okay. So this involves an array of shapes. Okay. Same idea. We're going to be counting up shapes depending on the question. Okay, so let's read the questions first before we figure out what ratio. I think I got a lot of U's about being kissed by a shark. That's okay. Iris is right. Whatever you do to the top, you gotta do whatever you do to one side, you gotta do the other side. So that's one of my favorite math sayings. Because when you do algebra, whatever you do to one side, you have to do the other side. All right. So number 9. How many shapes are there total in the array? Which is good to know. So let me move this over a bit because I'm off center and I have a little bit of paper to work here. So let's count the shapes. I don't like to spend too much time on things, so I'm going to skip count because I can see that there's 1, 2, 3, 4, 5 shapes. So I'm going to go 5, 10, 15, 20, 25. So there are 25 shapes in the array. So chances are, if I was going to do a probability, the outcomes are 25 shapes. Okay? Now, that can change because, say, I only want the probability of hearts to circles, or squares to hearts, or squares to circles. Then your outcomes are going to change because the totals are going to change. Okay? But let's not get ahead of ourselves. If you were to select one shape at random from the array, what is the probability it will be a circle? So it's still looking at shapes, so I know that my outcome number, the second part of my ratio, is still going to be 25. Now I want to isolate how many circles there are for my event, because my event is that you're pulling a circle out of the array. So we're going to count 1, 2, 3, 4, 5, 6, 7, 8. 8 out of 25 is going to be my probability. We can't simplify that anymore because 8 is an even number, 25 is an odd number. So it's not going to be helpful for us to try and divide it because we'll just get a decimal, so we'll leave it as it is. Okay? Let's look at number 11. If you were to select one shape at random from the array, what shape do you have the greatest probability of selecting? So this is a common sense question because the highest probability is going to be the shape that has the most in the array. So I know that there's 8 circles, okay, which means the probability for circles is 8 out of 25, okay? Let's count hearts, 1, 2, 3, 4, 5. Hearts are 5 to 25, which is an odds of 1 to 5 because I divided 25 by 5 and 5 by 5, so I got 1 to 5. And then finally, I have squares, and I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So then my odds are 12 to 25. So I have the odds of 8 and 25, 5 and 25, or 1 to 5, and 12 out of 25. So what is the greatest probability, or which shape are you most likely, the greatest probability to select? So you're going to pick the one that has the most. Okay, that's how I said you're just going to pick the one with the most. Because if we write all those probability ratios, then this one is most likely to happen. Okay? Now, I like question 12, but you are not going to have to do any percentages on your quiz. Okay? So this is just for your information. Okay? So which shape has a 32% chance, and it gives it to you here, 8 out of 25, of being selected? So what it's trying to show you is that 8 out of 25 is actually 32. And how they got that is your ratio is 8 out of 25, but it can also be written like this, which is actually just fancy division. So what this means is 8 divided by 25 is going to give me 0.32, which equals 32%. Okay? That's just a little look ahead because we're going to talk about percentages again. Okay? But that's why it looks like that. So it's just trying to give you a little bit of a nod saying, hey, you can also do these as percentages. Okay? And I know that Marco really likes percentages, and he's really good at calculating them. So that's why we get this here, okay? It's because the probability is 8 to 25, or we can write it like this, which is really just fancy division, which gives us this answer, which if we multiply it by 100, because percent means of 100, is 32%, okay? If you didn't understand that, don't worry about it. It's not on your quiz. All right. I think you guys have a handle on this. So I'm going to go to the quiz so that we can finish up for today. Okay? I'm going to scoot out a little bit. All right. Okie dokie. All right. So this is one of the test quiz. This is one of the tests that I brought home in my bag and I didn't take very good care of. So I'm sorry that it's crinkly. So This quiz is going to tell you whether it's asking you for theoretical probability or experimental probability, okay? And there's one really good way of knowing the difference, okay? One is it's going to say theoretical probability, and if it doesn't, it's probably experimental. The other thing is theoretical probability is not going to have any data attached to it. So if you look at this question here, it doesn't have a little chart telling me the different outcomes of somebody's experiment, okay? So if there's no experiment data, then it's going to be a theoretical probability question. Do I have any experimental probability? I don't even think I do. I don't think there's any experimental probability. Oh, nope, there is. All right, so we'll get to that in a second. So the first page is theoretical probability, and it's trying to see if you can give me the numerical probability. Like I said, don't give me words, okay, because we have to move past that. So number one, choosing letter A from the pieces marked A to E, okay? Theoretical means if you just do it once, okay? Spinning red on the spinner, again, if you just do it once. Rolling an even number on a cube, again, if you were just rolling it once. And choosing a number less than 30 from these papers, marked 1 to 20, that's trick. If you were to do it once, okay? Theoretical probability is just if you did it once, what should happen, okay? So let's look. At the next page, I'm having a problem turning it over. All right. So concept questions, you've seen these before. They're more about how you communicate your thinking, okay? So pay more attention to how you write down what you're thinking, okay? So why can you say that the probability of flipping a coin is 1 to 2 before you've even flipped a coin? Okay, so you can explain to me, and we've talked about that in class, okay? You're going to tell me the theoretical probability of this. Now this picture is not very helpful because it's going to be in black and white, so you're going to have to use your words, okay? And if it helps, draw them on top. There's nothing wrong with helping you visualize. And then you have to tell me why it's not 1 to 3, okay? And that's a little bit of a tricky one, so you need to make sure that you keep an eye on that spinner, okay? Let's look at number 4. Number 4 is now you're predicting. Remember we talked about predicting? Predicting is not just a random guess. You can't say 534 when there's only 5 tiles. That wouldn't make any sense. So you're going to predict it, okay, which is what probability is for the most part. And this is an experimental probability question because it's giving you 20 tries, which means you're going to figure out what the theoretical probability is, and then you're going to try and up that number to 20 tries. So instead of theoretical probability, which is based on one action, one event, based on what should happen, now you have 20 tries now. So how would you figure out, using the theoretical probability of 1 to 5, what would happen if you did 20 times, okay? Same thing with this. Now you're trying to predict without doing the experiment. You're going to figure out what the theoretical probability is, and then how are you going to figure out what would happen in 40 spins? Okay, do you actually have to do it? No, you just have to explain to me how you would go about it, okay? Same thing with this cube, and if it's helpful for you to have a number cube or dice, then you know I have a bunch of them, and they're silent, so you can work on them at your desk. And then the number of times the papers from 1 to 10 are selected, okay? So you're just going to make sure that you read very carefully in 15 picks, okay? So it might be helpful for you to underline different parts of information, because these are the types of questions where UPS comes in very handy. You have to understand your question, so look for that important information. Plan what you're going to do with it, and then solve it, okay? And the back. Okay, and this again is is another experimental probability question that requires you to predict, okay? So if you're going to spin this spinner 20 times, how are you sure that you will probably land on red 10 times? And you're going to tell me how that's true, okay? Don't say I used my brain. That's not an answer in a math test. All right, because you're supposed to use your brain. If you're using something else, I don't understand. And then number 6, this is where I'm going to let you use your words, okay? And you're going to link what those words are: impossible, certain, likely, or unlikely. Those are your choices, okay? Don't make up any words. Mo, because you make up lots of words. So just make sure that, so you got a probability of 0, 1, blah, blah, blah. And then you're just going to write the word underneath it, okay? And that's it. It seems really long, but it's not. And it seems very confusing, but it's not. I think you'll be fine. Like I said, though, if you go through this paper, I think that this is a good paper. And then if you want to test yourself, there's another spinner probability page. There's an easy one and a little bit tougher one. It's tougher because there's more choices. And there's repeated choices. So this might be a good one to try. And then if you are just really digging probability, and you're like, hey, I wanna do my number sense again, because I know you love number sense, then you can do the probability of numbers problems, okay? And that would be good practice too. All right, so that's all I'm gonna do for this live stream. I'm sorry to have made you wait, but now I think I have worked out all the bugs, and I think I'm ready to go. If I have to do another live stream, I think that you're going to do great on the test tomorrow. You'll do great. Okay? So don't worry so much. And use your brains. Okay? And don't forget, if there's something that you don't understand, we can go over it another time. And just love you. Okay? So I will answer a couple questions after I end the stream. And if you have any other questions, you can have your parents send them to me on Remind, or you can email them to my email address, or leave them on the blog comment, because all of those come to my cell phone. I got a question. What about the science test? What about the science test? This is, what is it, Math Masterminds? This isn't science in Math Masterminds. But seriously, the science quiz is 5 questions on circuits. You're going to get a circuit map, and you're going to tell me, will it light? So the activity that you should have done today in science, that's pretty much what you will be doing tomorrow in multiple choice questions. Okay? Safia, you are allowed to use your brain. Just don't say on the test that you use your brain. Okay? Oh, Khadija the Grammar Police. Nice. All right. So if you have any other questions, you know the ways to get them to me, or you can ask me in the morning, preferably after my coffee. And then I think you guys will be fine. And I'm going to sign off now. So, like I said, if you have any other questions, just let me know. Night, guys.